we're going to look at a few indeterminate forms that are only used in the AP Calculus BC course. So we're very familiar with 0 over 0 and infinity over infinity, but the first one that we're going to deal with that we can still use L'Hopital's rule for is the indeterminate form of infinity times 0, or 0 times infinity. So in this case, we have the limit as x approaches infinity of x times the sine of 1 over x. And if you plug in infinity for that, you have infinity times the sine of 1 over infinity, which is the same as infinity times 0, because 1 over infinity is 0, and the sine of 0 is 0. So this indeterminate form is fairly easily dealt with. We're just going to take the x and rewrite it as a 1 over x. So we'll still have the sine of 1 over x, but we're going to rewrite this as this x as a 1 over x. And so effectively we've turned this into a limit that is now 0 over 0. In doing that, it means we can now apply L'Hopital's rule. The AP test will always want you to indicate that you've used L'Hopital's rule, and you'll take the derivative of both the numerator and the derivative of the denominator. The derivative of sine of 1 over x is cosine of 1 over x times the derivative of 1 over x, which is negative 1 over x squared, and then over the derivative of 1 over x, which is also negative 1 over x squared. We'll see quickly that the negative 1 over x squareds should cancel themselves out, and we're just left with the cosine of 1 over x. When we plug in infinity, this just becomes the cosine of 0, which is 1. The next indeterminate form that we're going to look at is infinity minus infinity. So what we've got here is 1 over the natural log of x minus 1 over x minus 1. The limit as x approaches 1. So if we plug in 1 for both the x's, we end up with 1 over 0 minus 1 over 0, which is infinity minus infinity. So the most common way to deal with this is to find a common denominator. So we're going to rewrite this as the limit as x approaches 1 of x minus 1 over ln x times x minus 1 minus ln x over ln x times x minus 1. We've multiplied the first fraction by x minus 1 over x minus 1 and the second fraction by ln x over ln x. And now when we combine those together, we've got the limit as x approaches 1 of x minus 1 minus ln x over ln x times x minus 1. And if we plug in 1 to this now, we end up with 1 minus ln 1, which is 0. So 0 in the numerator. And the denominator, we end up with the ln of 1, which is 0, times 1 minus 1, which is also 0. So we end up with 0 over 0, and we can now use L'Hopital's rule to solve this limit. So, using L'Hopital's rule, we got the limit as x approaches 1 of derivative of x is 1, minus 1, its derivative is 0, and minus ln x becomes minus 1 over x. And in the denominator, we end up with the natural log of x times x minus 1, so we'll have to use the product rule. The derivative of natural log of x is 1 over x times x minus 1 plus ln x times the derivative of x minus 1, which is just 1. When we plug 1 into this, we get 1 minus 1, which is 0, over, when we plug 1 in down here, we end up with 1 over 1, which is 1, times 0. 1 minus 1 is 0. So 0 plus ln 1, which is 0. So we end up with 0 over 0. So once again, we'll apply L'Hopital's rule. So using L'Hopital's rule, this will end up being the limit as x approaches 1. In the numerator, the 1 cancels out when you take the derivative, becomes 0. And the negative 1 over x will become positive 1 over x squared. And in the denominator, This 1 over x times this x minus 1, we can distribute that out. That'll probably make our life a little bit easier. 1 over x times x, this piece right here, just becomes 1 over x times x is x over x, or 1, minus 1 over x, plus ln x. So as we take this derivative, the 1 goes away. The minus 1 over x becomes 1 over x squared. And then the plus ln x becomes plus 1 over x. And we end up with, when we plug 1 in, 1 over 1, so 1, over 1 over 1 plus 1 over 1, which is 1/2.